Chapter 4, section 4.1. First, now we want to talk about kind of graph that they are not continuous. And we want to find the domain of these rational functions. The rationals because the x is at the denominator. So variable will be at the denominator like this one. So as you see on this one, there is a break in the graph. So the numbers here, as you get close, if you're coming from -1 and move to the right toward the 0, what happens is in that case, the y value keep dropping, goes all the way to -infinity. So like if you take a point here, this point, this is a x and this is a y value. But as the x getting close to 0, the length of the y value is getting negative larger, goes all the way in. On this one, since this function, this piece of the graph is dropping, as x increase, the y decrease. So this type of graph, since it goes to -infinity on this side and positive infinity on the other side, there is a domain is all the numbers except 0, because the graph, when it reaches to the 0, it doesn't cut the y-axis. So domain is all the numbers except 0. Why? Because when you substitute any number for x, 1 over that number is the value. But if you put x equals 0 here, what happens is you take 1 and divide it by 0. 1 divided by 0 is undefined. So that means graph can reach almost to 0, but not 0 itself. And there is a discontinuity at x equals 0. They call this line the asymptote. Is the line that will cut the graph, and one end, its graph goes all the way to positive infinity, the other end goes to negative infinity. Like on this one, what's the domain? What number would make the whole thing undefined? X equal 1. So for rational function, which again, we call it rational because it does have a denominator and it has an x at the denominator. For rational fractions, to find a domain, you always take the denominator, set it equal 0. That's the number that you don't want. You want to exclude 1. Why? Because when I put a 1 here, look, then you have 3 over 1 minus 1, or 3 over 0, and 3 over 0 is undefined. Any number that make the denominator 0 is not in the domain. So when the graph goes to positive infinity on y and negative infinity on y, then this is a vertical asymptote. If the same thing happened on this side, on the x or horizontal axis, then they call it horizontal asymptote. See, the graph goes all the way to positive infinity, and here it goes all the way to negative infinity. All right. There are two types of asymptote. One is the horizontal, like for instance, let's say I have these equations and they ask you to find the vertical asymptote. The vertical asymptote, to find the vertical asymptote, all you need to do is take the denominator and set it equal 0 and find the number. That's the number that must exclude on the domain. Means when you want to find the domain, which is always x, is all the numbers except 1. Why? Because if you put a 1 here, then it would be 3 over 0 is undefined. So anytime you want to find a vertical asymptote, you have to take the denominator equal to 0. Another example, let's say y is 5x over 5x plus 1 over x minus 3 and x plus like 5. How do I find the domain? Domain is all the numbers that make the denominator equal 0. So 3 and -5. Means domain is all the numbers except -5 and except 3. And also to find the vertical asymptote, we could take the denominator and set it equal to 0. That gives you the vertical asymptote. So these two numbers that are excluded in domain, they also give you the vertical asymptote. So, and they all are vertical. So like here, one of the asymptote is, we normally use the broken line, is x equal 3. The other asymptote is x equal -5. See? To find the vertical asymptote, you take the denominator, set it equal 0. So these two numbers, since they are not in domain, you could use them as vertical asymptotes. But for horizontal asymptotes, we have a formula that it depends on the highest power of numerator and highest power of denominator. For instance, here, the numerator, the highest power of x is 1, and the highest power is 2. If this value or this number is less than that, if n is less than m, the graph has line of y equals 0 as a horizontal asymptote. So this one, this is the horizontal asymptote. It doesn't have any vertical because the bottom, we cannot set this equal to 0 because it can never be 0. 3x2 plus 1, regardless what the value of x is never 0. Why? Because x is to the power of 2. So this graph doesn't have vertical asymptote, but it does have horizontal asymptote. The other one, you take the x2 minus 1 and you set it equal to 0. So that would give you two numbers. When you take the denominator and set it equal to 0, it gives you two numbers, -1 and 1. These two are vertical asymptotes, 1 and -1. How do I find the horizontal asymptote? How do I find the horizontal asymptote? You take the, okay, so I'm sorry, for vertical asymptote, you take this equal to 0 and you find those. Now, how about the horizontal asymptote? Horizontal asymptote, we look at the highest power of the numerator and highest power of the denominator. Both of them has 2. And here, when n is equal to m, the graph has a over n over bn as the horizontal asymptotes. Okay, so example, let me show you some examples on that. Let's say you have this kind of equations. Okay, to find the horizontal asymptote, the highest power of x is 2 and highest power of x is 2. If these two powers are equal, then you could take the coefficient and divide. So the horizontal asymptote is y equal 3. Let's say you have another one. Something like that. You don't care about the rest. Horizontal asymptote is the highest power is 3, the highest power is 3. It's the ratio of these two. So it would be -15 over 3 or -5. F of x and y are the same thing. Highest power is 1, highest power is 1. So coefficient of this is -1, coefficient of this is 1. -1 over 1 is -1. So vertical asymptote is -1. Okay, this one, The highest power is 2, the highest power is 2. So vertical asymptote will be 1 over 1. Even when you simplify, then you have x minus 1, x, the highest power is 1, highest power is 1 over 1 is your one of the asymptote, which is this one. To find the other asymptote, you take the denominator equal to 0. For vertical asymptote, all you need to do is take the denominator and it's equal to 0. So there are two asymptotes. One is the vertical one is x equal to 3. Horizontal one is 1. All right. So now examples. Find the domain. Domain is all the numbers. What number would make the denominator 0? 5. So domain is all the numbers except that. What number make the denominator 0? -1. You don't want to put -1 here. So domain is all the numbers except -1. What number would make the denominator 0? x2 minus 1 equal to 0. To find those, you write it as that. You take each parenthesis equal to 0. So there are two numbers that must exclude from the domain because any of this number would make the denominator 0. Therefore, the whole thing is undefined. So to find the domain in case of fraction with the variables at the denominator, take the denominator, always set it equal to 0. X plus 1 equal to 0, x is -1 and so on. We factor each of this, but we cannot simplify it anyway. All the numbers except 4. What number would make the denominator 0? 4. This one, for vertical asymptote, we always take the denominator equal to 0. So x2 equal to 0 or x equal to 0. For the other asymptotes, we don't have any power. Let's say power is 0 for the x on the top, and here is 2. If the highest power at the top, which let's assume is 0, is less than 2, then y equals 0, or x-axis is the horizontal asymptote. The reason I put x equals 0, so you could actually see there is always an x, but any number or whatever to power 0 is always 1. So when you see just a number, that means if there's an x sitting next to it, the power is 0. And this is less than. If n is less than m, then y equals 0. This one, you have +1 and -1. See, the both power are 1. Coefficient of this is +1 because it's -1. So when you divide, it gives you -1 as an answer. So you have the solution for all this, you could tell. Like in this one, remember to find the horizontal asymptote, you always look at the highest power of x on the top and the highest power of x on the bottom, which is x2 plus blah, blah, blah. Asymptote is, you take the denominator, set it equals 0. Asymptote is -5. To see which one of these has -5 as an asymptote. This one is x equal -5 as an asymptote. This one also has -5. But the only difference is take a number like -7. For -7 in this graph, the value of y is the negative, right? So when you put a -7 here, then would be 3 over -2. So it give you, but here, For -7, these functions, it gives you a positive one. So this is not the right function, because when you put a -7 here in the equation, -7 should give you a negative number like this one. So you find the asymptote that would eliminate 2 of the graph, just give you 2. And then in these 2, you could just pick a point and substitute for, take a point of x, substitute for y, and see which one of these 2 graphs has that. What's the asymptote of this? Take a denominator set equal to 0, x equal 3. X equal 3. This is also x equal 3. All right, but take a point and substitute. This one also has horizontal asymptote too. To find the horizontal asymptote, the power of x, the coefficient of x is 1, this is 1. So y equal 1 is the horizontal asymptote. But this one doesn't have horizontal asymptote. So this is x equal 1. Y equal 1 is horizontal asymptote, and x equal 3 is the vertical asymptote. Y equal 1 is the horizontal, x equal 3 is the vertical asymptote. So this one has 2 vertical and horizontal asymptote, this one doesn't. So this is the correct answer. You have x2 and you have x2. In this case, the value of y is 3/1 or 3. So that's one of their asymptote, which is the horizontal asymptote. It's 3. See, they both have x2. In that case, you find a ratio of 2 coefficients. x2 coefficient or number sitting next to it is 3. Number sitting next to this one is 1. It's 3/1. That is your horizontal asymptote. To find the vertical asymptote, you take the denominator set equal to 0. So x2 minus 9 equal to 0. X minus 3 times x plus 3 equal to 0. Or so x is -3 and 3. So there are 3 asymptotes, 2 vertical and one horizontal, which is this one. 2 vertical and 1 horizontal. None of the other 3 that has 3 asymptotes, just this one does. It has just if you take the denominator and set equal to 0, x is equal to 4, which is this one. Now, to find the other asymptote, at the top, you have 4. At the bottom, you have like x2 minus 2x minus 8, x2 minus 8x plus 16, okay? It doesn't have any x at the top. Let's say x is 0. If the power of x at the top is less than the bottom, then y equals 0 is one of your asymptote. It would be your horizontal asymptote. Okay, so in this case, this is your horizontal asymptote, which is line of y equals 0 or x-axis. X-axis is y equals 0. And the other is x equals 4. We should find it here. All right, I think the rest you could figure this out.